Hello. In this video we're going to be solving exponential equations. And so what I have here in number 1 is 2 to the x power equals 33. Now we know that if we had, say, 2 to the x power equals 32, that x would be 5 because 2 to the 5th is 32. But 2 to the what power makes 33? There's not a nice whole number that we could take raised to the second with a base of 2 to get 33. So we know it's going to be somewhere just over 5, we just don't know what that number is somewhat more exactly than that. And so this is where we're going to use our logarithms to help figure this out. So what I can do is, if I take both sides of this and take the logarithm of both sides. This is a very legal mathematical move, so I'm putting both things inside the log. And, I mean, everything should be the same, right? If these two are truly meant to be equal, then they have the same log, the same base, so it's a matter of 2 to the what power makes 33. But now that I've done this, I have some helps here, because since I can raise this thing to it's 2 to the x power, when I have an exponent inside a logarithm, I'm able to pull it out front to show multiplication. So it's x times log of 2 equals log of 33. And so then to get x by itself, we would divide by log of 2. So that's gone. X is equal to the same thing as log of 33 divided by log of 2, which evaluates out to approximately 5.044. Let's look at number 2. In number 2, I have the e as my base raised to the x power equals 52. And to make things a little easier on myself this time, since I have a base of e, why don't I take things to the natural log this time? So I'll take both sides, the natural log of both sides. So the natural log of e to the x equals the natural log of 52. The natural log of e to the x, we have one of our properties from a while ago tells us that that's just going to be x. So our x is whatever the same thing as natural log of 52 is. And so the natural log of 52 approximates out to 3.951. That is a 9 there. Okay, how about 3? In number 3, what we're looking at is 7 times 3 to the x plus 6 equals 10. In order to be able to do what I was doing in number 1, I need to have just the base and the exponent by itself on the one side. So I'm going to subtract both sides by 6. And so we have 7 times 3 to the x power equals 4. Next, I'll divide both sides by 7. So 3 to the x power is equal to 4/7. Okay, so I'll just do the natural log of both sides this time. I'll rewrite it over here. So the natural log of 3 to the x equals the natural log of 4/7, which means I'm allowed to bring the x down. And so then it's a matter of just divide both sides by the natural log of 3. And so x is going to be whatever the natural log of 4/7 is divided by the natural log of 3, which approximates to negative 0.509. Okay, so that's how you would solve an exponential equation where you have an unknown in the x value or in the exponent. For now, we're done.